Let us do another solved example. In this example, we are given with a capacitor in the form of two concentric spherical shells. We have two concentric spherical shells, the inner shell of radius A and the outer shell of radius B. Now this is the capacitor given to us, and if right now it has free space between the two shells, but if there wasn't a free space, let us say there was a dielectric medium on the surface of A, and this dielectric medium has thickness T. Now because of this dielectric medium, the capacitance of the system will change. Now let us say that this dielectric medium has a dielectric constant. Let us assume it is K. Now if there were no dielectric, that is the in initial position, let the capacitance of the system be equal to C naught, which would be given by 4 pi epsilon naught AB upon B minus A. This formula we have derived in previous videos. So this is the capacitance when there was no dielectric. After the introduction of dielectric, to find the capacitance, we first need to find the potential difference between the shell A and shell B. That is, we have to find VA minus VB. So to find this, we need to recall a formula that we did in the chapter of electric potential, that potential difference V is equal to minus of E dx. If the potential difference is VA minus VB, then it will be equal to minus of integral of minus dx, and the limits will be from B to A. So using this concept here, if we do this, then we can divide this entire integral into two parts, where the limits will be from A to T and from T to B. Now that means that in the first term, the limit will be from A to A plus T, because the radius of dielectric surface will be equal to A plus T. A is the radius of inner shell and T is the thickness. So from A to A plus T, and then from this point to the outer surface, so it will be equal to E dot dx from A plus T to B. Now the minus sign I have removed here because I have changed the limit, I have reversed the limit, so that will negate the minus sign. Now solving this, E is equal to Q upon 4 pi epsilon naught R square. E is equal to Q upon 4 pi epsilon naught R square. This is the general formula of E. Now using this formula here, we can write pi epsilon naught. Now this is the permittivity of free space. Now because we have T, which has dielectric constant K, so it will be multiplied by K. So this will be the entire formula of the electric field multiplied by 1 upon R square from here, and it will be integrated from dr. So I'll change dx from dr because we are integrating r. The distance here is r. Plus the second term, similarly we can write from A plus T to B, and it will be written as Q upon 4 pi epsilon naught K. Sorry, there will be no K here because the dielectric ends here. Then after this there is free space, only epsilon naught, so no K in this term, and it will be Q upon 4 pi epsilon naught dr upon r square. So this is the term that we have to integrate. Now if we take Q upon 4 pi epsilon naught common, and we integrate this, and solving this, now it leave the solving part to you. The final expression after the solving that we will get will be A plus T into B minus AK plus AB into K minus 1 whole divided by KAB into A plus T. So this will be the expression that you will get after solving the integration and putting in the limits. So now the capacitance of the new system, we can say it is C. It will be equal to Q upon VA minus VB. So if we put the value of VA minus VB here in this equation, then Q will be cancelled out, and the final expression that we will get will be 4 pi epsilon naught KAB A plus T upon this will be the final capacitance after the dielectric is introduced. Now if we are asked that what is the change in capacitance between the initial and the final, then we have to find out delta C, which will be equal to C minus C naught. So if you solve this, put the value of C and C naught in this equation, and if you solve this, you will get the expression 4 pi epsilon naught into B square K minus 1 T upon K B minus A whole square, and this will be your answer to this question. Now if we are given the values of A, B, K and T and all these values, then we can put the values directly into this question, and then we can solve it to get the final answer.